This video is for section 1-2, sets and variables. Again, I want to remind you, this only highlights concepts and skills that are going to be in this section. You should still read the section in your textbook, study the vocab words, and look at the worked out example problems. Let's start. One vocabulary word you're familiar with already is variable. This is any symbol that may represent any element of a specified set. It is common to use letters of the alphabet as variables, such as X, Y. Capital letters work as well. Next, domain. This is the set whose elements may be replacements for a variable. Domain is also called the replacement set of the variable. Here's an example. If set S contains the elements 0, 2, 4, and 6, and we're told the variable X is an element from set S, then the domain for X is the numbers 0, 2, 4, and 6. Domain are all of the numbers that could be used for X, and we're told that X is an element of set S. So anything in set S is the domain for variable X. Next, an open sentence. This is a sentence that contains a variable. And here's an example open sentence. X plus 2 is equal to 6. So we have the word sentence here. We're talking about mathematical sentences, statements created using math symbols. An open sentence gives a pattern for various math sentences that are obtained by replacing the variable with each element of its domain. Some of these sentences may be true and others may be false. Here's an example. Write all of the sentences obtained from this open sentence if the domain of X is this list of 4 elements. So let's take each one of those and substitute it where the variable is. First, 0 plus 2 equals 6. This is a sentence. Next, 2 plus 2 equals 6. Next, 4 plus 2 equals 6. And then the last number to put in is 6 plus 2 equals 6. All of these follow the pattern given by the open sentence. We're substituting different numbers in for the variable X. Notice that some of these statements are true and some of them are false. This one's false, this is false, this is true, and this last one ends up being false. The solution set of an open sentence is the subset of the domain for which the open sentence is true. In that example we just did, what number from that list made the open sentence true? And that was the 4. So the solution set of our open sentence is the number 4. Each element of the solution set is said to satisfy the open sentence. The solution set elements are also called roots or solutions of the equation. The word we'll use most often is solutions. We will talk about solving open sentences in algebra class. Here's an example. Determine the solution of 2x minus 3 equals 11 if x is an element of the set 6, 7, and 8. We're asked to solve this equation, figure out the solution for x, and we're given a list of possibilities. So from this domain, which of these 3 numbers works for x? That would be x equals 7. 2 times 7 is 14, subtract 3 is equal to 11. We're going to encounter statements that look like this in the algebra book, so we need to know how to speak this. When you see the brace, the words that you would say are the set of. After the brace, you'll notice a variable, and what you would say is the numbers x, or the numbers represented by x. The colon is the phrase such that. And then this entire piece right here gives the conditions or a description of the solutions for x. So once again, the set of all numbers x such that x is an element of S and x plus 2 is equal to 6. Next, here's an example for somebody to volunteer to read out loud in class. I'll pause the video for that. Okay, what is the solution set for the above statement? We're looking for all numbers x such that x is an element of this list or x is an element from this list. The solution is 2, 3, 4, and 5. X can be any of those numbers, and that would satisfy that condition. Next, we have an example. List the members of the following subsets of the set of integers. Remember that the integers are 0, and then your positive whole numbers such as 1, 2, 3, 4, and so on, and the negative versions of those numbers. Question A, k is equal to the set of numbers x such that 3 plus x equals 11. What is the solution set for x? The only number that works is 8. So the solution set contains the number 8. Question B, R equals the set of numbers S such that S plus 2 equals S plus 3. What is the solution for S? This time there is no number that can work, so you write empty set. There's no number you can substitute for S and add 2 to it and get the same result as adding 3 to S. Question C, Y equals the set of numbers M such that M minus 5 equals 10, and M is an element from this set of numbers. What is the solution for M? Let's try the 3 numbers that were given to see if any of them work. 15 minus 5 equals 10? Yes, it does. 15 is part of the solution set. Let's try 20. Does 20 minus 5 equal 10? No, it doesn't. And let's try 25. Does 25 minus 5 equal 10? No, it doesn't. So the solution set has only one element in it, just the 15. Let's summarize. In this lesson, we reviewed the concept of variable and discussed open sentences. It's possible to find the solution set of an open sentence by finding all of the numbers that make the sentence true.